This video lecture is for the students of class Bsc Ag Honours Part 2nd Semester 1st in the subject Agricultural Engineering. The topic of the lecture is IC Engines, Introduction and Working Principles. I am Dr.C.P. SIGAR, working as Associate Professor in Agricultural Engineering in BBD Government College, Chimanpura. Definition of engine. An engine is an apparatus or machinery which converts one form of energy into useful work. Example, heat engine. A heat engine is a machine which converts heat energy into mechanical energy. Heat is generated by the combustion of fuels such as coal, petrol, diesel, CNG, LPG, etc. Heat engines are classified into two types. First is external combustion engine and second is internal combustion engines. Example of external combustion engine is the steam engine, where the combustion of fuel takes place outside the engine to heat water in a boiler, and the steam thus formed is used to run the engine. In the case of internal combustion engine, the combustion of fuel takes place inside the engine cylinder itself. The thermal efficiency of external combustion engine is usually in the range of 15 to 20%, which is very low compared to the internal combustion engine. The thermal efficiency of external combustion engine is about 40%. IC engines can be further classified as stationary or mobile, horizontal or vertical, and low, medium or high speed. The two distinct types of IC engines used for either mobile or stationary operations are diesel or compression ignition engine. Second is petrol or carburetor or spark ignition engine. Types of heat engine. Heat engine can be classified into two types: external combustion or internal combustion engine. Example of external combustion engine, as we have learned before, is steam engine, whereas internal combustion engine can be further classified. It can be classified based on the fuel used in the engine, and the examples are diesel engine, petrol engine and gas engine. If IC engine is classified on the basis of ignition of fuel, then it can be classified into two types: spark ignition engine, which is also known as carburetor type engines, and second, compression ignition engine, which is also known as injector type engines or diesel engines. Internal combustion engines can also be classified based on the working cycle. On the basis of working cycle, it can be classified into two types. First is the 4-stroke cycle engine and second is 2-stroke cycle engine. Spark ignition or the carburetor type IC engine. The principle of operation of spark ignition engines was invented by Nicholas A. Otto in the year 1876. Hence, SI engine is also known or called the Otto engine. In this engine, liquid fuel is atomized, vaporized and mixed with air in correct proportion before being taken to the engine cylinder through the intake manifolds. The ignition of the mixture is caused by an electric spark, and therefore it is also known as spark ignition engine. Example of SI engine are the engines which run on petrol and gas. Now we will learn about compression ignition or the diesel IC engine. The principle of working of compression ignition engine was found out by Rudolf Diesel in the year 1892. Hence, CI engine is also called the diesel engine. In this engine, only air is drawn in the cylinder and compressed so that it attains a very high temperature. Thereafter, liquid fuel is injected in the cylinder under high pressure, which ignites when it comes in contact with the compressed hot air. Example is diesel engine. Now we shall learn about the working principle of IC engine. The principle of working of both SI and CI engines are almost the same, except the process of fuel combustion that occurs in both engines. In SI engines, the burning of fuel occurs by the spark generated by the spark plug located in the cylinder head. The fuel is compressed to high pressures and its combustion takes place at constant volume. In CI engines, the burning of the fuel occurs due to compression of the fuel to excessively high pressures, which does not require any spark to initiate the ignition of the fuel. In this case, the combustion of fuel occurs at constant pressure. A mixture of fuel with correct amount of air is exploded in an engine cylinder, which is closed at one end. As a result of this explosion, heat is released, and this heat causes the pressure of burning gases to increase. This pressure forces a close-fitting piston to move down the cylinder. The movement of piston is transmitted to a crankshaft by a connecting rod so that the crankshaft rotates and turns a flywheel connected to it. Power is taken from a rotating crankshaft to do mechanical work. To obtain continuous rotation of the crankshaft, the explosion has to be repeated continuously. Before the explosion to take place, the used gases are expelled from the cylinder, fresh charge of fuel and air are admitted into the cylinder, and the piston moved back to its starting position. The sequences of events taking place in an engine is called the working cycle of the engine. The sequence of events taking place inside the engine during the working cycle are as follows. First is admission of air or air-fuel mixture inside the engine cylinder. This part of the working cycle is called the suction stroke. Second is the compression of the air or air-fuel mixture inside the engine, and this part of the cycle is known as compression stroke. Third is injection of fuel in compressed air for ignition of the fuel or ignition of air-fuel mixture by an electric spark using a spark plug to produce thermal power inside the cylinder. This part of the working cycle is known as the power stroke. The last part is the removal of all the burnt gases from the cylinder to receive fresh charge, and this part is known as exhaust stroke. So the working cycle of an engine comprises of 4 strokes. First is the suction stroke, second is the compression stroke, third is the power stroke, and the last is exhaust. Please note, charge means admitting fresh air into the cylinder. In the case of compression ignition engines, diesel engines, or admitting a mixture of air and fuel into the cylinder in the case of spark ignition engines.